In this video, we're going to take data from a MongoDB database and turn it into a working web app using just Python. We'll build a simple bank CRM that lets you search for customers and update their details. And when we're done, we'll deploy it to the web with a single click. Everything from the backend logic to the user interface will be built with Python using Anvil. The complete code for this project is available in the description, so you can follow along at your own pace or refer back to it later. Anvil is a platform for building full-stack web apps with Python. No HTML, CSS, or JavaScript required. Here's what we'll build. First, we'll create an Anvil app and design a CRM interface with drag-and-drop components. Next, we'll connect to MongoDB Atlas to fetch customer data and display it in our interface. Then we'll add search functionality and the ability to update customer information. Finally, we'll secure the app with user authentication and deploy it to the web. By the end, you'll know how to build and deploy a full-stack web app on top of your MongoDB database using just Python. Here's my MongoDB Atlas cluster. Atlas is MongoDB's fully managed cloud service that takes care of hosting and scaling for you. I'm using Atlas here, but you can follow along with any MongoDB setup, whether it's self-hosted or running locally. For this demo, I'll be using the customers collection from MongoDB's sample analytics dataset. It's a sample banking dataset with customer names, emails, account IDs, and membership tiers. If you'd like to use the same dataset, I've linked instructions in the description below. You can also use your own MongoDB data and adapt this approach to your own database structure. Now let's head over to Anvil. Create a new app and choose the Material Design 3 theme. In Anvil, your app's interface is built using forms. You can think of a form as a page in your web app. They have a visual design that describes how they look and a Python class that describes how they behave. We are currently in Form 1, which is a default startup form, the first page that will be displayed when our Anvil app is opened. Before we start designing, let's do some housekeeping. Let's rename the app to Bank CRM and change the app color scheme to Mykonos Light. Close these tabs and rename the startup form to Main Form. This is the form editor, where you can build your app's UI by dragging and dropping components onto the page and writing Python code. Over here on the right is a toolbox, where you will find Anvil's drag-and-drop components. Every component in Anvil is a Python object, which means you can access and manipulate them directly from code. When you add a component to a form, it becomes an attribute of that form, and you can reference it in the code using self. Now that you know how forms and components work, let's design the user interface for our CRM. We'll start simple and build it up step by step. From the basic components section, drag and drop a label onto the title slot. Double-click and set the text to Bank CRM. In the Properties panel, give it an icon and change its role to Headline so that it stands out as the page title. Next, we want to display a scrollable list of customers. For this, we'll use a repeating panel, which is ideal for displaying dynamic lists of data. Repeating panels display the same UI elements repeatedly for each item in a list, which is perfect for showing multiple customers. Under Layout Components, drag a repeating panel onto the form and rename it to Customers Repeating Panel. Double-click on the repeating panel to open its item template. The item template is a subform that defines how each element in the repeating panel will be displayed. It was automatically created for us when we added the repeating panel. Let's rename it to Customer Template. Now back in the form editor, we can design what each customer card will look like. Drag and drop an outlined card from the theme components onto Customer Template. This card will contain the details of each customer. Next, drop a label onto the card. This label will be used to display the customer's name. Let's call it Name Label and change its role to Title so the text appears bold and larger. In Anvil, every form has a property called Item. By default, it's an empty dictionary, but we can set it to any data that we want. In this case, self.item will hold a single customer object passed in from the repeating panel. To display the customer's name, we'll bind the label's text property to the name value in self.item using data bindings. Data bindings lets you link a component property directly to a Python expression, and Anvil automatically keeps them in sync. Click the link icon next to the label's text property and enter self.item name. That's it. The label will now automatically display the customer's name from self.item with no extra code. This is equivalent to writing self.namelabel.text equals self.item name in the form's code. Now let's add the rest of the customer details. Under the name label, add a flow panel for the email. Flow panels arrange components horizontally, which is great for placing a label and its value side by side. Inside the flow panel, add a label with the text email and make it bold. Just beside it, add another label that would display the customer's email address. Let's name it email label and bind its text property to the email key in self.item. We'll do the same for the username. Add another flow panel below the email row with a bold username label and a label for the username value. Name it username label and bind it to the username key in self.item. Finally, let's add a label for the number of accounts and name it accounts label. We'll use an F string in the data binding to display how many accounts the customer has. Perfect. Our customer card is complete and all the data bindings are set. When we set the repeating panels items property to a list, Anvil automatically creates a customer template for each element in that list and assigns that element to self.item. Because of the data bindings we've set up, each card is now populated automatically with the customer data. Our UI is all set up. Let's connect to MongoDB and fetch the data to populate our repeating panel. First, we'll get the MongoDB connection string. In the MongoDB Atlas cluster window, click Connect, choose Drivers, and select Python 3.12 or later. Copy the connection string. We'll use it in a moment. Like most web apps, Anvil apps run code in two different places, the client and the server. The client runs in the user's web browser. This is the front end of your app, where your user interface lives, along with the Python code that makes it work. Server code, on the other hand, runs securely on Anvil's cloud server. This is the backend of your app, where you write Python code to handle sensitive operations like database connections and business logic. You can also use Python packages here. We will connect and interact with the MongoDB database from a server module, where it will be secure and private from the browser. Let's add a server module and paste our MongoDB connection string here. Save it in a variable called connection URI. Anvil server modules are normal Python environments with the ability to import any Python package you like. To connect to MongoDB from our server module, we'll need to add the pymongo package to our app server environment. In App Settings, go to Python Versions, and in the Add a Package field, enter pymongo. We'll leave the version blank to install the latest release, then click Add. Great. Now we can import Mongo client from pymongo and create our MongoDB client using the connection URI. You'll notice that the connection string has a placeholder for the database password. We definitely don't want to hard code that into our app. Instead, we'll store it securely using Anvil's App Secret service. Click the blue plus button in the sidebar and select App Secrets. Let's create a new secret called MongoDB PWD and set the database password as the value. I've blurred mine out for security. Click OK and you'll see a confirmation that the secret has been created. You can always reveal a secret later by clicking the View Value button, and Anvil will send the app owner an email and notification when it's viewed. Now back in the server module, notice that anvil.secrets is already imported. Let's retrieve the password using anvil.secrets.getSecret. We'll use this value to replace the password placeholder in our connection string. One final step before we query our database. We need to make sure the database accepts requests from our server. Since our database connection code runs on Anvil's server, it uses Anvil's outbound IP addresses, which you can whitelist. For this demo, we'll simply allow access from anywhere in MongoDB Atlas. Now let's create a function that fetches and returns a list of customers from the database. We'll limit the results to 20 customers and convert the object IDs to strings for simplicity. To make this function callable from client-side code, we'll decorate it with anvil.server.callable. Now we can call this function in the main form and pass the list of customers to the customer's repeating panels items property. Back in main form, let's switch to code view. We'll create a function that calls our server function and assigns the list of customers directly to the repeating panels items property. Anvil.server.call lets us call server functions from the client side. It calls our getCustomers function on the server and returns a list of customers. Now let's call this function when the app loads. In the init method, right after self.init components, we'll call loadCustomers. Now let's run the app and see our data. Perfect. We can see our customers displayed straight from MongoDB Atlas. The connection is working and our UI is displaying the data nicely. Great. Let's now add search functionality so users can quickly find specific customers. First, add a text box to the main form, just above the repeating panel, so users can search for customers. Name it Search text box and give it a placeholder. Now we need to update our server function to handle search queries. Let's update getCustomers to accept a search query parameter. If there's a search query, we'll use MongoDB's regex to search across name, email, and username fields. And if not, we'll return all customers. Back in the main form, we'll update load customers to pass the text from the search box to our server function. Perfect. Now load customers will filter results based on what's in the search box. Finally, let's make the search box call load customers when enter is pressed. Add an onPressEnter event to the search text box. This function will run whenever the user presses enter. In the event handler, we'll call load customers to refresh the results. Now let's run the app and test the search. Perfect. When I search for Brian, the list updates to show only matching customers. And when I search for Elizabeth, we see those results. If I clear the search and press enter, we're back to seeing the first 20 customers in alphabetical order. Excellent. Our search is working perfectly. Viewing data is useful, but a real CRM also lets you make changes. So next, we'll add the ability to update a customer's email. In Customer Template, add a button next to Email Label. Name it Update Email Button and give it the text Update Email with an edit icon. Now let's add an on-click event to the button. When the button is clicked, we'll display a pop-up where users can update the customer's email address. Let's create the pop-up form. Add a new blank form and call it Update Email. In the Update Email form, add a label with the text New Email and a text box beside it for entering the new email address. Name the text box New Email Text Box. Now let's bind this text box to display the current email. Click the data binding icon next to the text property and bind it to the email key in self.item. This will display the customer's current email in the text box. We also want to capture whatever new email the user types in. To do that, we need to enable Writeback. With Writeback enabled, when the user types a new email into the text box, it automatically updates the email value in self.item. When we show this form as a pop-up, we'll pass Customer Template's item property into this form's item property. Since both forms will reference the same customer object, Writeback changes to self.item will automatically be reflected in Customer Template. Perfect, our update email form is ready. Now let's use the alert method to show this update email form in a pop-up when the update email button is clicked. Switch back to Customer Template and import the update email form at the top. In the click event function, let's create an alert and pass the update email form in as the alert's content. We also want to pass self.item to update email, set a title, and make the pop-up large. We will also add save and cancel buttons to the alert. We've stored this alert in a variable called update email. When the save button is clicked, update email will be true, but if cancel is clicked, it will be false. If save is clicked, we want to call a server function that will update the user's email. This function will accept the customer's ID and the new email value from self.item. Thanks to Writeback, self.item's email now contains the new email address the user typed in. Now let's head over to the server module to define the server function that updates the customer's email. This function will accept the customer's document ID and the new email. In MongoDB, every document has a unique ID field of type object ID. Earlier in the getCustomers function, we converted these object IDs to regular strings for easy serialization. Now we'll convert the string back into an object ID to update the document in MongoDB. Now that the email is updated in MongoDB, we need to refresh the customer list so the UI shows the new email. Back in Customer Template, we need to trigger a refresh after updating the email, but the load customers function is in the main form, not here. To communicate between these forms, we'll use custom events. Custom events let forms communicate with each other. Custom event names must start with X- to distinguish them from built-in events like click and pressed enter events. After the update, let's raise a custom event on the customer's repeating panel, called xRefreshCustomers. Now in the main form, we'll bind this event to the load customers function. Since load customers is now being used as an event handler, we'll update it to accept event arguments. Now whenever customer template raises the event, the main form automatically reloads the customer's list. Perfect, let's test it out. Edit a customer's email and click Save. Great. The email updates and the list refreshes instantly. Right now, anyone who has the app URL can access our CRM. That's not ideal for a real application. For the final step, we'll secure the app with authentication. Anvil makes authentication easy with the user surface. It handles sign-up, login, password resets, and user permissions out of the box. Let's add the user service to this app. On the user management screen, we can see the users table, which contains lists of all registered accounts. This table is a data table that is automatically created when you enable the user service. Data tables are Anvil's built-in Postgres-backed database for storing application data. For the simplicity of this video, we'll allow visitors to sign up and uncheck confirm email address before users can log in. In a production app, you'd probably want to keep email confirmation enabled and carefully manage who can sign up. Now in main form, after initializing components, call anvil.users.login with form. This will present the login screen once the app loads. Finally, to ensure our client callable server functions can only be accessed by logged in users, we'll add require user equals true to the callable decorator. This ensures only authenticated users can access those functions. And that's it. Let's test it out. When we run the app, the login form appears. I can create an account with an email and password and then log in. There, we have our CRM working securely. Now we're ready to publish and share our app with the world. Anvil apps are automatically hosted, so publishing is easy. Click Publish, click on the URL, and open it in the browser. There it is, our app is live and working on Anvil's free hosting. You can also add a custom domain or self-host if you prefer. Now let's sign in. Search for a user and edit their email. Back in MongoDB, I can search for that user and see that the email has been updated. You've just built a web app with only Python and connected it to a MongoDB database using Anvil. Anvil actually comes with its own built-in database called Data Tables, which makes it super easy to store and manage data right inside your app. But if you already have an external database like MongoDB, PostgreSQL, or others, you can connect those too, just like we did here. Try it out with your own database and let us know what you build. You can find links to the docs, sample code, and the MongoDB sample database in the video description. Anvil is free to use, so you can start building right now. If you found this video useful, please like and subscribe for more Anvil content. Thanks for watching.